And to reach to this conclusion, we have looked into the octal, binary and separately in the last video. While discussing all of this, the takeaway was this, that how many numbers you have to pass. This is the key thing. How many numbers you have to pass to get at first n digit decimal number, then that is pass all one digit, you have to pass all two digit, and you have so on, you have to pass all the n minus one digit. Similarly, you can say this for any base, so not only decimal number. And we have seen that the base of decimal is 10, and to get to the first two digit decimal number, how many numbers we have to pass? That is 10 to the power 1. The base of decimal is 10. To get to the first three digit decimal number, how many numbers we have to pass? It is equal to 10 to the power 2. See, this was the decimal. In case of binary, the base was 2. How many numbers we have to pass to get to the first two digit binary number? 2 to the power 1. The base was 2. How many numbers we have to pass to get to the first three digit number? 2 to the power 2. The base was 2. How many numbers we have to pass to get to the first four digit number? Is 2 to the power 3. You see, there's a relation with base. Similarly, in case of octal, base is 8, and how many numbers we have to pass to get to a first two digit octal number? It is 8 to the power 1. How many numbers we have to pass to get to a first three digit octal number? This is 8 to the power 2. So how many numbers you have to pass to get first two digit number in base B? It is B power 1. To get first three digit number in base B is B power 2, and so on, to get first n digit number in base B, it is B power n minus 1. So this observation that we made for decimal or for binary or for octal, this is true for any number system of base B. Okay, any number system of base B. So in this video, what I am going to do is to arrive at this any arbitrary number system of base B. Okay, take a number system with base B. In base B, there will be B unique digits, including 0. Why I am explicitly mentioning 0 here? Because we will see in a while that 0 amounts to nothing. Actually, 0 amounts to nothing. 0 amounts to nothing. So number system was initially devised to help human beings for counting things. Okay, we have seen that in the previous video. So and 0 means nothing. 0 means nothing. So for example, if this is a container, in it you have objects. Okay, and if you are asked how many objects are there, you will say 2, because human beings talks in terms of decimal, so we will say there are 2 objects, right? If the container does not have any object, then you would say there is 0 object. So 0 amounts to nothing. 0 amounts to nothing. Okay, consider any one digit number in base B. Consider any one digit number in base B. If it is B1, the ith value of this is equal to B1. For example, if you take 7 in base 10, then this is the seventh. You will say that this is the seventh number. This is seventh number in base 10. Okay. Why? Because in reality, including 0, this has to be 8th number, but 0 amounts to nothing. So we will say that this is the seventh meaningful number in base 10. Similarly, if you write here 7 in base 8, then you will say this is the seventh number in base 8. This is seventh number in base 8. In base 8. So this is what it is. If there is only one digit number, then the ith value is b1, and you can write it as b1 into b to the power 0. b1 into b to the power 0. Consider b2 0. b2 0. b2 0 is the first two-digit number with b2 at second place. With b2 at second place. Right. Find out the ith value for b20. This is one digit number, and then with 1 you will have 0 to b minus 1. With 2 you will have 0 to b minus 1. So on. With b2 minus 1 you will go from 0 to b minus 1, and then you will get the first element b2 at the second place, and it will go from 0 to b minus 1, and this is your number. This is your number, b2 0 in base b. So how many numbers we have to pass to get to b2 0? This is b. Similarly, for 1 you have, this is b, this is b, this is b. So all of this is what? b2 minus 1 into b. Okay, so what is going to be the ith value for b2 0 in base b? It is equal to b2 minus 1 into b plus b. Ith value for b2 0 in base b. What is ith value? Ith means b2 0 is the ith number in base b. Okay, so b2, this is equal to b2 into b. b2 into b. So why I am taking b2 0 in base b? It is because I just want to show you that what it means with b2 at the second place. Okay, now take any two-digit number. Consider any two-digit number. So consider any two-digit number. Consider any two-digit number. Consider any two-digit number at base b. For example, b2, b1, base b. Okay, so what is the ith value? What is the ith value? We know that the ith value for b2 0 is b2b. So what is this? So this is b2. So it is b2 into b. b2 into b. And after b2 into b, this is b2 into b, and this corresponds to b2 0. This corresponds to b2 0. Now this b1 corresponds to what? From b2 0 you will go to b2 b1. b2 0 you will go till b2 b1. So this will be equal to b1. This will be equal to b1 from 0 to b1 minus 1. Okay, so you can write this as b2 into b plus b1 into b to the power 0. Okay, take this example, b1 0 0 base b. So why I am taking this? What it is? This is the first three-digit number with b1 as the at the third place. So from 0 to b minus 1, and then all from 1 to so on b minus 1, you will have from 0 to b minus 1, right? 2 to b minus 1 and b minus 1 to 0 to b minus 1. Okay, and the first 3-digit number is 1 0 0. This is the first 3-digit number. Okay, and this will go from 0 0 to b1 minus 1 b1 minus 1. After this number, that is b1 minus 1 b1 minus 1. Okay, listen, don't confuse it. For example, in case of decimal, this is 99. Okay, so so why I am writing here 0 0? Because when you have to get to the first 3-digit number, you don't only have to include all this, you have to include this by adding zeros to the left. Okay, that's why it is 0 0. So you will go from, you have to include everything in the 3-digit number. So how many numbers are, okay, so 0 1, then 2, it will go from 0 0 to b1 minus 1 b1 minus 1, and so on b minus 1, sorry, it is b1 0 0, right? So till b1 minus 1 0 0 to b1 minus 1 b1 minus 1, and then you have b1 0 0 to b1 minus 1 b1 minus 1. Okay, so what is the ith value? This is b. Okay, so this is b, then this is b, this is b, this is b. So what it is? It is 1 to b minus 1. It means this is b minus 1 into b. And what is this then? How many numbers are there? B minus 1 into b plus b, which is equal to b square. This is equal to b square. Okay, so it means that this is b square, this is b square, this is b square. So what is the ith value? What the ith value will be? Ith value will be from 1 to b1 minus 1, you will add b square for b1 minus 1 times b1 minus 1 into b square plus b square, and this is equal to b1 into b square. So b1 0 0 base b, what is the ith value for it? This is equal to b1 into b square, and b1, or you can write it as b1 into b square plus 0 into b power 1 plus 0 into b power 0. We will see that. For now that you have got ith value for b1 0 0, take any b1 b2. Okay, 1 minute. I should have taken b3 0 0. Anyways, let's take b3 b2 b1 base b. What is the ith value for it? And you will find it out using the same process. So from till b3 0 0, the ith value is b3 b square. So B3 0 0 to 0 B minus 1, then B3 1 0 to 0 B minus 1, so on so on so on. B3 B2 minus 1 0, so on. B2 minus 1 B minus 1, so on. And the next will be B3 B2 0 2 B3 B2 B1, so on so on. B2 B minus 1. This is B, this is B, this is B. And to get when you are here, B2 B1 minus 1, so this is B1. Okay, so what should be here? From 0 to B2 minus 1, it means B2 into B, B2 into B plus B1 into 0 plus B. So this is same as B3 B square plus B2 into B plus B plus B1 into B to power 0. Okay, so we have arrived at this. So each of this thing, B to the power n minus 1, B to the power n minus 2, B square, B to the power 1, B to the power 0. These are you say the weights. These are the weights, okay, for that position. These are the weights for that position. So enough for this video. We will continue from here in the next video. Okay, thank you.